On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at another example of related rates that involves the area of a circle. In a previous video, we did do an example where we had a very similar situation, except we were trying to find the rate of change of area with respect to time. We were given the rate of change of the radius with respect to time in example 1, but example 2 is a little bit different. The area of a circle is decreasing at a rate of 30 square inches per hour. That sentence right there tells me that dA dt, the rate of change of area with respect to time, is equal to negative 30 square inches per hour. I used a negative because the area is decreasing, so we can think of this as like a puddle, a big circular puddle that's drying up. So if it dries up, the circle is going to get smaller and smaller and smaller. So therefore, dA dt equals negative 30 square inches per hour. At what rate is the radius of the circle changing, inches per hour, when the area of the circle is 40 square inches? So we're trying to find the rate at which the radius is changing. We are trying to find dr dt. Since we're dealing with a circle and we have area and we have a radius, the formula to use here is area equals pi r squared. And we can go ahead and differentiate this right now, but we're going to see that we're missing something that's very important. Let's go ahead and differentiate all of our variables with respect to time. The derivative of a is 1, but let's remember to tack on our dA dt. So I'm just going to write dA dt instead of 1 dA dt. The derivative of pi r squared with respect to time, let's pull the 2 down. So we have 2 pi r. This will be to the first power. I'll just leave that off. And let's remember to tack on our dr dt since we are differentiating with respect to time. Now, we know what dA dt is. That's going to be the negative 30 square inches per hour. 2 times pi. What is the radius? Okay, that's where we have to be careful, because in order for us to find dr dt, which is what we're looking for, we have to have something to plug into here, which we do have, but we don't know the radius yet. If we go back and read this problem a little bit more, we're trying to find the rate of change of the radius when the area of the circle is 40 square inches. So let's come back and look at area equals pi r squared. And at a particular instance, when the area of the circle is 40 square inches, so area is 40 equals pi r squared. Let's not round anything, but let's solve for r so that we can plug that in over here, and then we can solve for dr dt finally. So dividing by pi to get r squared by itself, and then taking the square root of both sides. And again, I will not round anything. So therefore, we have a radius that is equal to the square root of 40 over pi. And since this is a radius, that is just going to be plain old inches, not square inches, because we're not dealing with area. This is a radius. Taking all of this information and plugging it in, dA dt, we said this was negative 30 square inches per hour, is equal to 2 times pi times our r value, the square root of 40 over pi inches, times dr dt. To get dr dt by itself, since everything is getting multiplied by dr dt, we can divide by 2 times pi times this square root of 40 over pi inches. Now, all of these units that I'm writing down may confuse you, but it does help you make sure you get the correct units in your answer. Since we're finding a rate of change of radius, it even says it up here, inches per hour. I want to show you, though, how we will get inches per hour when we work with our units. And this is very helpful, especially if you're in a calculus class, working with units correctly. So notice I am taking the negative 30 here in my numerator, and I am dividing it by all of this stuff over here that's technically getting multiplied by dr dt, but we want to move all of this over here to this side. That's why I'm dividing by it. And typing that in correctly, we get negative 1.3 roughly, because we are rounding to the nearest tenth. But what are our units of measurement? Up top, we had square inches per hour. In our denominator, when we divided by all of this stuff, we have inches down here because we had that inches with this square root of 40 over pi. So that's the inches in our denominator. If we take square inches, which is really inches to the second power, that's square inches, and this is inches to the first, we can think about it as if we're subtracting exponents. This inch will get rid of one of those inches up there with the square inches, leaving us with negative 1.3 inches per hour. This is equal to dr dt. Therefore, when we go back and look at this problem, if the circle is decreasing, the area of the circle is decreasing at a rate of 30 square inches per hour, when the area of the circle is right at 40 square inches, that radius is decreasing at a rate of 1.3 inches per hour. Notice I used the word decreasing. That's what the negative represents. And the reason why we have to include the negative here, because it doesn't say at what rate is the radius of the circle decreasing. It does not use the word decreasing. It says at what rate is the radius of the circle changing. So if we're going to use a signed number here, we need to use negative 1.3 inches per hour. If you were to write out a sentence, you could say the circle is decreasing at a rate of 1.3 inches per hour. And again, just make sure you round correctly. And the extra step here was to find a radius to plug that into that unknown. Therefore, we could solve for dr dt. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.